Today I'm going to talk about configuring um, multiple span and tree protocol on HP switches. So I have a topology here. Um, Basically, we have uh, two physical two physical switches that are bundled into one logical switch using IRF. So if you are not familiar with IRF yet, I suggest you watch my video about configuring IRF. Um, so we have um, a logical core switch here, and we have one axis switch, and uh, so switch one, switch two. They are both axis switches. So I have already configured um, uh, multiple spanning tree on all of the switches. I'm just gonna show you how I configured it. So let me open the core switch. Let me console into the core switch and console into switch one and console into switch two. So let me see if I can squeeze in all these all these windows, terminal windows into the screen. Uh, so okay, so this would be easier for us to see the configurations the and also refer to, while looking at the topology. So let me go here. So this is uh, a procedure that I got from the HP website. This is the link here. I also have a Word. This is the link. So let me show you the configuration of the MST configuration on core switch. So actually, I have some verification commands here. So display current configuration would be much faster. So display current configuration pipe begin STP. If you want to see all the MST configuration. So I can't show the topology, but um, you know what? Let me go back to the topology and just explain this. So this is so basically first step is you need to enter the MST region view, or second step here, and configure the MST region. So in this case, I'm just reading this region name, region dash name HP. Um, um, uh, it's recommended that you should use the same region name and level on all the switches just for the configuration digest to match on all of them. Reading just the note here. And this is step 4 is this is where you map the instance to the VLANs. So in this case, I'm mapping instance 1 to all the VLANs. So VLAN 1 to 4094 and configure revision level. Default is 0. Um, so you can actually specify the default revision level here. So 1. So here, this is the instance or the VLAN to instance mapping, and uh, step 6. This is the command that you can use um, to display the region configurations that are not activated yet. And step 7. This is the as you can see here on the core switch. This is where this is the command that you use to activate the MST region configuration manually. And of course, um, this is step 8 is the command that you can use to, let me um, use that command. You can use to display the activated configuration information of the MST region. So region name HP. This is what we that this is that this is the region name that I configured. Revision level and configuration digest. Like I said, this has to match on all the switches, and this is the instance and VLANs mapping. So instance 1 again is mapped to all the VLANs. Let me do a show VLAN. Display VLAN. So I only have 4 VLANs configured, but here this is the all the VLANs that you can configure on this particular switch. So that's the configuration of the core switch. The MS2 Radiant configuration on the core switch, and um, configuring core as the root bridge of the STP instances. Let me show you this configuration. This is actually this part here. As STP instance 1 root primary. So I configured this core switch as the root bridge. Um, I configured this core as the root bridge for STP instance 1. So system view STP instance. So by default, all VLANs and an MST region are mapped to the um, instance 0. This is by default here. So you actually have to make uh, your switch as the uh, root bridge for instance 0 and instance 1 because uh, instance 0 is enabled by default. So instance 0, this instance 0 is, I did not configure that. And so 2, and you can also specify a priority, but I'm not doing that option. I'm just what I did. I chose the root option and say primary. You can also set. I mean, choose secondary if you have a secondary switch for your VLANs. And um, let me go back to the STP configuration here. And BPDU protection. This is this is to uh, this is the command that you can enable on this switch. So it says here when the BPDU guard function is enabled on the devices, when edge ports receive configuration BPDUs, MSTP will close these ports and notify the NMS that these ports have been closed by MSTP. So basically, when this BPDU protection is configured on the switch, when you have a when you have edge ports and let's say one of the and uh, someone connects a switch to one of the edge ports, uh, basically that edge port will be closed uh, by MST. So in other words, when you have an edge port, you are not supposed to connect a switch to that port. Um, so that's basically um, uh, what's the function of STP function BPDU protection. So this is next is STP global configuration. I mean STP global enable. I actually did not configure this when I think this is enabled by default, but you can also just configure it just to make sure that STP is configured or enabled globally on the switch. So that's the configuration of the core switch or configuration of the MST on the core switch. And so let me show you now how I configured the the access switches. So system view access switches. So let me do this command again. So the uh, the region name, like I said earlier, should be the same on all the switches. So region name is HP, revision level is 1, instance. So instance 1 is also mapped to all the VLANs on this switch, and this is the how you um, activate the region configuration. And STP is enabled on the, I mean, STP BPD protection is enabled on this switch as well. And this is how you verify that STP is enabled globally on the switch. So pretty much the same configuration on the core switch. I mean, pretty much the same configuration as the core switch. The difference is we configured, so let me compare here. So the difference is we configured this command here, STP instance one root primary. For of course we want our core switch to be the primary bridge, uh, the primary bridge, right? And let me go to switch to system view and display current configuration begin STP. Um, so, excuse me. So pretty much the same configuration as the switch one. So I'm not gonna explain it again. So let's do some verification here. So let me do this command on the, let me try to fix the Windows, terminal Windows. So let me do this command on the core switch. So as you can see, there's no root port on the um, core switch because, of course, this is the root bridge. So there's no root ports. And this is the, and you see that MST's instance 0 and 1 are configured. And so I already did this command earlier. Let me show you the configuration digest, because like I said, it has to match on all the switches. As you can see, the switches have the same configuration digest. See, and display STP instance one. So let me just close these windows first and expand this window. So bridge ID, this is the this is the MAC address of the core switch. And if you actually check IRF, that's the bridge MAC address of the IRF, because this core switch is, I mean, the IRF is configured on this uh, core. So what else? So so bridge aggregation is forwarding bridge aggregation one, which is connected to uh, which is the connection going to switch one, and bridge aggregation two forwarding also the bridge aggregation connected connected to switch two. So they are both, all the ports are forwarding, and has the role of designated port. So display STP brief. So this is a nice command to verify the role and state of the ports. So designated and forwarding. So let me go to switch one. So let me do this command, display STP root. So switch one, its bridge aggregation is the root port, and so this here, and gigabit 1/01/1/0/1 is actually designated ports. So here, forwarding also, and this is the root forwarding. And I already did this configuration or this command earlier. And let me do this command, display Mstp instance 1. So bridge 1, uh, this is the this is excuse me, this is the bridge ID of this switch. So default is bridge ID. Uh, this is the default bridge ID, and this is the MAC address. So sorry, this is the bridge priority. This is the priority, and this is the MAC address. So bridge ID is the combination of the priority and MAC address. So as you can see here, root bridge election. So uh, the switch that has the lowest bridge ID becomes the root bridge. And if the bridge ID is the same on all the switches, uh, the tiebreaker is the MAC address. So this is the again this is the bridge ID, and this is the root ID. So we configured this command on the roots on the core switch. Where is it? This here. So we made instance 0 in 1. Uh, I mean, we made the core switch to be the root bridge for instance 0 in 1, and its uh, priority is 0, and this is its MAC address. So we are on switch 1. So bridge aggregation is forwarding, and it is the root port. And here, this is these ports here are bundled into a bridge aggregation. I mean, these ports are are the are the physical ports in the bridge aggregation. And this here, this is the one that is connected to this host. So it is in forwarding state, and the role is designated port. So let me go to switch to. Oops. So switch to, of course, it's bridge aggregation 2 is the root port, as you can, oops, as you can see here. And this is hmm, the let me go to core switch. I actually did configured. Let me do this command. Oh, okay. I was actually looking at this here. The priority of the broad bridge is still set to the default value. It's because this here I only made the core as the root for instance 1, but not for instance 0. So let me fix that. Primary save configuration. So if we do this command again, uh, we'll see that the root bridge has priority 0, and, and this is its MAC address for instance 0. So next is, I already showed you this command, display instance Mstp instance 1. So just like switch 1, the bridge aggregation 2 is in forwarding state and is the root port, and gig Ethernet 0, I mean gig Ethernet 1/0/1 is in forwarding state and designated port, and display STP brief. So this is another way of verifying the role and states of the ports. So again, the bridge aggregation 2 is the root port, and gigabit Ethernet 1/0/1 is the designated port, and it's in forwarding. So that is how you can configure uh, MST or MSTP on HP switches. So that's it in this video. Thanks for watching.